Hey guys, how you doing today? We're back here starting a new chapter, chapter 17, which is on compound events. Compound events is going to basically be a carryover of what we did in chapter 16, except they're going to include more steps. So let's take a look at 17.1 on compound events. We'll go straight to part one. Going to watch some of these video clips here, and hopefully you can hear them okay.
In probability situations, an action is a process with an uncertain result. In the previous topic, you worked with actions that involved only one step or choice. For example, spin the spinner once. This is a one-step action. Multi-step actions involve more than one step or choice. For example, spin the spinner twice. This is a two-step action. Consider a different type of action. Choose one person from the group. This is a one-step action. Now consider a related multi-step action. Choose four people from the group. This is a four-step action.
Okay, so I think we're going to skip these last two parts here because, again, you can see this part we would think would be relatively simple. If we take a look at what we've got here, it says how many steps or choices does each action involve. So in this particular situation, we have to choose one fruit and we have to choose one drink. So that obviously should be a two-step action. We, on the next one, are assigning first place, second place, and third place ribbons. And so obviously, three things that we have to do. Therefore, it's a three-step action. And then on the last one, you have to choose a six-character password. Obviously, a six-character password means you have to pick six characters, and therefore, it is a six-step action. Issues with that? I hope not. Let's move on. Again, one of our favorite topics, food. If we take a look at this, we have to pick a sandwich filling, and we've got to pick a type of bread that we're going to put it on. So if we take a look at this, a sandwich filling, we're going to choose one of the following from here. That will be one step. And then we're going to choose the type of bread, which would be another step. So all told, that should be a two-step action. Okay, two-step action. Moving on. That is all of part one. You should find that extremely easy, one would think. Moving on to my next little piece of the puzzle, part two. All right, so in this particular situation, we've got compound events, okay? Compound events. This is going to be very important that you understand what this is. It's a multi-step action. So if I spin a spinner, for example, twice, you can see that it might say, hey, I want you to spin a red, then spin a green, and we would indicate this by using parentheses, almost as if it was an ordered pair, R comma G. If we looked at it for choosing four people, you could see that we have a pile of people over here, and we would, our event would be choose a boy, then a girl, then a girl, then a boy. Again, we would write it as we have seen the ordered pair situation, parentheses B comma G comma G comma B. If we went three number cubes, we have a blue cube 2, red cube 6, green cube 2. And so we would indicate that with the colors, a blue 2, a red 6, and a green 2. And then obviously if something happens to you guys in the morning, especially the girls, I would think, choosing a shirt and a pair of pants. We want a yellow shirt and a light blue jeans. So we would go yellow with the light blue. So that's a compound event, a multi-step action. Moving on to piece two. Little video clip here. So check each group of jewelry on the right that shows a possible compound event for the action. Note that the action that they're talking about, they want to choose a necklace, a bracelet, and a ring. Obviously, this would not be involved in this due to the fact that it's only a one-step action. We have a three-step action that should be taking place. On the top right, do we have a ring? Yes, we do. Do we have a necklace? Yes, we do. Do we have a bracelet? Yes, we do. So I would think that this one should work. How about on the next one? Do we have a necklace? Yes. But note that we have two bracelets. And if we have two bracelets but no ring, that's not going to work. And then on the third one, we have a necklace. We have a bracelet. And we do, in fact, have a ring. So I would think it's going to be these two particular situations. And they agree with us. Questions there? Okay, let's carry on to our next parts. Again, this looks like, we always love these first sections because the first sections seem to always be the easiest. The action, you're going to spin the spinner 4 times. Which of those show the compound event for this particular scenario? Number 1, you could cross out right away. Why? It's only got 3 events or 3 actions taking place. Could I possibly, on number 2, spin a blue, followed by a blue, followed by a blue, followed by a blue? Yes, you could. This would be unlikely if you go back to 16.1, but this is possible. Number 3, could I spin a red, followed by a blue, followed by a green, followed by a blue? Yes, I could. So we would think that the 2 answers that should work would be number 2 and number 3 choices. Forwarding ourselves to, that's all of part 2. So if you didn't find that too difficult, I would think part 2, that would be, you know, we're looking at 10 out of the 15 questions at this point, should be relatively simple, one would think. Let's take a look at what part 3 brings us. We're not going to have to do a whole lot of math on this section. You will, however, have to do that. We'll carry this on into section 2, and that's where you're going to have to start dropping some sample spaces and multiplying some fractions and those types of things, I would think. All right, here we go.
When you work with a compound event, consider whether the events that make up the compound event affect each other. 2 events are independent events if the occurrence of one event does not affect the probability of the other event. The first action is choose one tile at random and replace it. The first part of the compound event is choose A. The second action is then choose a second tile at random. The second part of the compound event is then choose a B. So the compound event is AB. Before any action takes place, the probability of choosing a B tile is 2/11ths. Since you replace the A tile after choosing it, the probability of choosing a B tile is still 2/11ths. The probability of the second choice is not affected by the first choice. The events choose A and choose a B are independent events for this action.
All right, so let's take a look at this real quick. This is where we're going to play this off into the section number 2. So in this particular scenario, one thing does not affect, the first event does not affect the second situation. All right, so for example, me being here at school today has no bearing on what Mr. Mayhew is going to eat for lunch today. All right, those would be independent events. One does not affect the other. We move ahead here a little bit, one of the things we're going to find out is we're going to eventually take event 1 2/11ths. This won't be till the next couple sections. And we would say, I'm going to multiply that by this particular piece, which is also 2/11ths. This is going to give me 4 out of 121. So in this particular situation, if I gave you this pile of letters and I said, hey, what's the chances or what's the probability of you pulling a B, replacing it, and then pulling a B again? And so the chances of that happening, the probability of that happening is 4 out of 121. So you can see the chances, that taking place, very unlikely. All right, let's move ahead to my next piece. Next slide, should I say. Oops, let me go back here for a second. I failed to do this part right here. So they're going to talk to you about dependent events now.
Two events are dependent events if the occurrence of the first event affects the probability of the second event. The first action is choose one tile at random and set it aside. The first part of the compound event is choose A. The second action is then choose a second tile at random. The second part of the compound event is then choose a B. So, the compound event is also A, B. Before any action takes place, the probability of choosing a B tile is 2/11. Since you set aside the A tile after choosing it, the probability of choosing a B tile becomes 2/10 or 1/5. The probability of the second choice is affected by the first choice. The events choose A and choose a B are dependent events for this action.
All right, so we took a look at this in real life. I mean, the weather, for example. If it is, 15 degrees outside, what you wear to school is dependent upon the temperature in a lot of situations. Obviously, in the wintertime, you see us with heavy coats on, and when we come back out of summer, you see us with shorts and t-shirts and those types of things. So in that particular situation, real life scenario, that's a dependent scenario where the weather affects what you wear to school. Move on to slide 2 here. And so in this particular situation, once again, we're taking a look at this and we're saying, okay, if I have an action, and let's think we're playing sorry in this particular scenario. Player 1 chooses a game piece. Player 2 chooses a game piece. Obviously, if player 1 chooses a red, player 2 cannot choose a red. That is no longer an option. So this would be representing a dependent event. Over on this next action, we're going to spin the spinner twice. That's going to be an independent situation. Why? Because what you spun the first time has no bearing on what you spin the second time. Moving on to slide 3. Which compound event is composed of independent events? So let's take a look at number 1 there. Roll a standard number cube twice. You get an even number on each roll. Is the second roll affected at all by what you rolled on the first roll? No. So this one would represent an independent situation. Let's take a look at the second one. I toss a coin 1 time, and then I roll a standard number cube 1 time. The coin lands on tails. The number cube lands on a 5. Did the coin landing on heads have any bearing on the cube landing on a 5? No. So in this particular situation, both of these would represent an independent scenario. All right, that should do it for us on 17.1. Good luck. If you need anything, please give me a shout via email. Have a good afternoon. Bye.